All right, we had a question about question 8. It says a machine is driving piles for a wharf in a river estuary. So it's like a small canal type bit, a small opening if you like. It does this by lifting a heavy weight 4 meters directly above the pile and then slams down on it after it's released. The impact drives the pile into the riverbed. The acceleration of the weight is 4.9 meters per second squared. What's the initial velocity of the weight? All right, so let's take a look at drawing this. So again, I always tend to draw diagrams of these things. So first of all, we're looking at exercise 23.03. This is question 8. And so we've got a heavy weight that is released, and it comes down and hits a post, which it is driving that post into the riverbed. That's essentially what it's doing. Please focus. Thank you. All right. So the weight's released, the weight's attached to something, and it's released and it slams down. And here the acceleration is equal to, and we're told it is, where is it? It's gone. Here we go. Yeah, 4.9 meters per second. So acceleration at the very start. So t must equal 0. It hasn't moved, so s must equal 0, but acceleration equals 4.9 meters per second squared. Okay, so that's where we are. So the first thing it says is, it asks us to calculate what is the initial velocity of the weight. Well, initial velocity, well, if t is 0 and acceleration is 0 and s is 0, we're not given any information about it, so we have to assume that v is also 0. So I would say question 8a, if if t equals 0, then I'll say then v equals 0 meters per second. We've got no information that would be otherwise. Yeah, so that would be my answer. Again, it's actually implying that because it doesn't give us any information, and we can assume that it's starting at rest, it's being let go. So if it's being let go, it must be stationary before it's let go. So that's how we would know that. That's the information we would have that would enable us to answer that. So that would be my answer.